Universidad Nacional de Quilmes student, and I will talk about an approach for doing behavior-driven development in Pharo. First, I will do a brief introduction to BDD and all its elements. Then I will show you a demo in Pharo using a tool I've started to develop. And finally, I will tell you some of the work left to do. So, behavior-driven development is considered as an agile methodology that helps to build a common language between all members of a project. And this is achieved by specifications. These specifications are the elements that will drive the code, and they work as an acceptance criteria. So these specifications should be human readable, so all members of a project can understand them clearly, and they should be executable, and this is a very important thing it's essential for BDD, because I, as a developer, can see if there is something failing, there is something passing, or if there is something pending, or it's all okay. So for that reason, the specifications are not simple documents. We need a language for writing the specifications. So a language for writing specifications has been designed. This language is called Gherkin, and it appeared with the Cucumber project. Cucumber is a BDD tool for Ruby. And then other implementations appear for Java, C#, Python, PHP, and more languages. Here we have an example of a specification written using Gherkin. As you can see, it's very easy to read, to understand. It's almost plain text. Gherkin has only a few keywords. And the structure of this specification is the following. We have features. Features represent little pieces of functionality of your software, of your application. In this case, if we are modeling a coffee machine, the part of serving coffee is a piece of functionality of the entire system. Features are often followed by a narrative that helps to... It's a kind of comment for the feature. It is only a good practice to write them because it is ignored by the runner, but it helps you to focus on the person involved in the feature, because features are written from the point of view of the user, and we can specify in the narrative the importance of the feature. Then we have scenarios. Features can have one or more scenarios. The scenarios describes interactions between the user and the application, and are composed of steps. Step describes in detail this interaction. We have three kinds of steps. Steps that are responsible for setting some initial context, those starting with the keyword given. We have a step that represents actions in the system, those starting with the keyword when, and those steps that check for expected outcomes of the system, those starting with the keyword then. So you probably are wondering how we get from these specifications to the code, how the computer knows what a step means. So the answer is that there is no magic yet, and it's your work as a developer to give any step a meaning. This is achieved by writing step definitions. The step definitions are code that responds to a step in Gherkin. Here we have two examples of step definitions. The first one is in Ruby, the second is in Java. The way to map a step definition to a step is by regular expressions, and this is nice because we don't need to write one step definition for each step. This will be too tedious. So, for example, here we are capturing a parameter in the regular expression represented by the red boxes, we are capturing any numbers, so this step definition should work for this step, given there is one coffee left in the machine, but it is the step definition will match a step with there are 2 coffees, there are 7 coffees, there are 42 coffees. So, and the parameters are defined by putting them in between parentheses, and the tool will take this parameter and will pass into the method. I will show this in Pharo in the demo. So, the BDD people suggest to work with BDD using a cycle very similar to the TDD cycle. But there is one important difference, and that is in the writing code phase, it can be too complex because a scenario can involve interaction with all the application stacks, since a user interface to a database. So it's a good practice to do little TDD cycles in this writing phase to ensure that small parts work, and then it's easier to get the scenario working. Well, it's time for the demo. I will show you a very simple example in Pharo. I will do example of a registration to this conference. So I open the image. Oops. And I load the tool. I call the tool Kiwi because it had to be something green. Yeah. Ruby has cucumber, but Pharo now have Kiwi. This is the user interface of Kiwi. We can specify the features. Configure some parameters of the runner and see the results. It's very basic, but well, I am starting by adding a feature. When we add a feature, the tool asks if we want to add a new feature or a feature in the image. We can store features by putting them in methods. I will show you one feature I have. The feature is a method returning a string with the feature content. This is useful if you want to keep the features in the image. But you also can load features from external files. So I will select this class for loading this feature. I have loaded the feature into the runner. If we take this feature as is, I will explain first what is the feature about. The feature has a title, this conference registration. It has the narrative. Remember, this is only a good practice. It is ignored by the runner. And we have one scenario that represents a successful registration to the conference. It says that given the Smalltalk conference, and I give my name and my email, when I try to register, then the registration should be successful. If we take this feature as is and we run it, we can see the results. There are 5 steps. So those 5 steps. One scenario and one feature. It says that the feature is undefined because we don't have indicated yet where are the step definitions. I already wrote the step definition, but I have to indicate in what class the step definitions are. I took the class. I will show you these step definitions. This is not of my tool. I think I found a bug. Well, step definitions are represented as methods. This method can be in any class you want. The method name can be what you want, but the important thing is the important thing is that we tagging this method with a pragma. This indicates that this method is a step definition. The pragma has a name corresponding to the kind of this step. I want this step to be a given step. And the parameter is the regular expression to match for steps. So this step definition will match this step. Here we have a step with a parameter. Here we are putting a sub-expression of this regular expression between parameters. And this parameter here represents an email. So this method took a parameter representing the email. And that's the way I decided to work with step definitions. Well, let's take a look at the code. We are creating an object representing the conference and store it in an instance variable because we need to remember that object in order to be used later in the next steps. Same here, we store the name of the attendee, the email, and we can go to the, when I try to register, we have the pragma with the when name and the regular expression. We create an attendee with the email stored before, and we add this attendee to the conference. And then steps. We have to write here some kind of assertion because we need to throw an exception if the expected value is what is not what we expect to be. But this class are not extending from test case. This class is not a test case. So I recommend it here to use a very nice framework called Mocketry. Mocketry is a framework for doing mock object, but it also has syntax for writing expectation like this. It's very real. It says that the number of attendees to the conference should be 1. And we don't need to extend from test case or something else. We can check the number of attendees by hand and throw an exception if we want. But I think this is very more nice. If we take this feature, I've added the class with a step definition. So if we run this, close that. If we run this, it says that we have 5 steps. We have a formatter printer for this step. It shows the name of the step and the method with the step definition that has matched there. So all step has a definition. All steps pass it. There is no error because I have implemented yet the code of the smalltalk conference. It's very simple. It's only had elements to collections and check for these elements. It's very, very simple, the domain. So I will show you another example, another feature. I'll choose. In this case, we have 2 scenarios. The second scenario represents a submitting of a talk. It says that given the Smalltalk conference, and I am registered with my name and email. When I try to submit the proposal with an abstract, and this is an element of Gherkin, of the Gherkin syntax. It is called multi-line strings. It can be passed after any step if we want. So I will show you how I do the step definition for that. Given the Smalltalk conference, it's the same step as the previous scenario. And the second step, I am registered with my name and email, is the same we do before with these steps. So we can reuse these step definitions this way. I have this regular expression for matching the step. Those represent the parameters email and name. And I call here the step definitions written before, so I can reuse that. Don't write this logic again. And when I submit the proposal, here we have the parameter representing the title of this proposal is this title, and we have an extra parameter with the abstract. This is passed automatically if the tool detects a multi-line string. It will pass to the method. It will find a method with the pragma, with the regular expression matching the step definition, and then we'll call this method with the right parameters. If we take this example and run it, we have one feature, we have 2 scenarios, and 9 steps, the 5 previous steps, and these 4 steps. All steps are passing. I will show you one more little thing, one element of the Gherkin syntax that is called background. If you see these scenarios, the first step is the same. So we are doing in any scenario, we have sharing some step. We have a mechanism in Gherkin to write this in one place and ensure that it is executed before every scenario. This is called background. And in the background we'll put the steps shared by all the scenarios. Okay. We move this step to the background because the tool will run it before every scenario. If we run this feature, it is passing again. I will go back to the slides. Well, because this tool is a testing tool, it can be tested by itself. This is very nice, and the Cucumber people have written many features that allows us to test any implementation of a tool with Gherkin syntax. Here we have an example of a long feature with many scenarios describing the feature. I took all these features. I took the features with the core functionality of Gherkin. I loaded into Kiwi, and it is running. So I am sure that the core functionality is passing. Of course, there's a lot of work to do. It's a work in progress. So I hope to get a stable release. But one essential things to have is step definitions to support C-side, Magma, and other frameworks used in the industry to do real BDD. The example I did show you before, it's a very simple example. Maybe this is not a good example for BDD. BDD deals with web frameworks and user interfaces and databases. So we need a way of write steps for testing, for pressing buttons, filling fields, and so on. And this is very important. I hope to implement that. There are other features in Cucumber, such as automatic generation of step definitions. That means you don't have to write the regular expression and the skeleton of a step definition. The tool automatically will write that step definition, and we go in this step definition and write the code. And also things related to reporting, to be in many formats. Then we need some mechanism for integration with the browser to make the developer experience more comfortable. Add-ons to the browser, or the integration with continuous integration with servers. Any idea on that, it's welcome. And other important thing is that Gherkin language is not only in English. The example I have shown you are in English, but Gherkin has many languages for writing the specifications. In Cucumber has almost 40 languages implemented. I implemented two of them, Spanish and English. It is very easy to write translation because Gherkin has only 10 keywords. And in the tool I implemented, the translations are in the image. So it's easy to contribute with translations. And I want to write some documentation for this. Today there's no documentation at all, there's only code. Write some tutorials, things like that. And a suggestion I received is to write a Pharo example chapter on this tool, on Mocketry, and other testing tools that are in the community. So if you have questions, this is the time. We can follow one of the two scenarios. No questions? Or are you reading this? It's very easy to read. It's Gherkin syntax. No? Well, if you are interested, there are some links to follow with the project. And well, this is the end. That's all. And thank you for listening. And we say that.